All right, welcome back. This is AP Pre-Calc. This is lesson 1.3, rates of change in linear and quadratic. Two main ideas here that we talked about is linear functions have a constant first difference or a constant rate of change. And the weird thing about quadratic functions is they have a constant second difference or a constant second rate of change. So what we can do is we can look at the rate of changes for these different tables and determine whether they have certain types of concavity. We can determine whether they're linear or quadratic, and then we're going to do the same idea with the one below. Okay, these are directly from the notes, but let's go ahead. Let's look at this idea. Looking at the first table, we can see that the change from 4 to 1 is we are subtracting 3, 1 to negative 1, and negative 1 to negative 2 have the following changes. So first thing, let's talk about concavity. Remember, concavity is found by looking at the rate of change. We just found the different changes between each value. Well, notice those rates of change. You start at negative 3, you go to negative 2, and then you go to negative 1. Realize those values are increasing each time. So one thing we know is the rate of change is increasing. Okay, looks like I need some more space. And the reason that's important there, where can I move? The reason that's important there is because that tells us what type of concavity this table has. When the rate of change is increasing, that implies that your function, the function k, is concave up. So k is concave up. Looking at the rates though, right? It was negative 3, negative 2, negative 1. Look at the second difference now. You would add 1 between the values. Between negative 2 and negative 1, you would add values. So the second conclusion you could make is this is a quadratic. The reason you can say it's a quadratic is the second difference, right? The second time we looked at the change between values, it was constant. Both the values, both the changes were 1. That's for the first table. Let's talk about the second table now. Again, you can find those rates pretty easily, those different changes. You might include the sign with it to really clarify. So plus 3, plus 3, plus 3. Notice those rates of changes are constant. Well, because it's constant, what does that tell us? Well, we said that linear functions have a constant first difference. That is the first difference. That is your rate of change. So we know that the function m is linear. Okay, we don't need to look at quadratic. We don't need a second difference because we're already able to make our conclusion. Third one, function p, same idea. Find your differences, see what's happening. Plus 6, plus 4, plus 2. Look at the second difference because it's not linear. Minus 2, minus 2. This looks like it would be quadratic because of the second difference. But let's talk about the concavity. Notice the first differences, right? Concavity is based off of your rate of change of the function. That's the first difference. Those rates of change started at 6, but it went down to 4. It went down to 2. So the rate of change for p is decreasing. So what does that tell us? Well, that tells us that this function, our function this time is p, so p is concave down. If your rate of change is decreasing, you must be concave down. So that's what we looked at for 1.3. That's the basic idea we have to understand. Let's apply that further. The directions on your notes tell you that this function is quadratic. So we know the table we're given is a quadratic relation. What that tells me is the second difference in our function, right? The second difference here has to be constant. Well, let's start by finding the first difference between the values we know. Between 24 and 31, you would add 7. Between 31 and 35, you would add 4. But we need a constant second difference. I know the difference between 7 and 4 is minus 3. I can apply that now. This difference has to be the same every time. So if I move this way, I'm going to subtract 3 again. So I took 7 minus 3, that gave us 4. So if I take 4 and subtract 3, that gives me positive 1. If I take 1 and subtract 3, that gives me negative 2. And if I take negative 2 minus 3, that gives us negative 5. Well, realize that gives you the change between each value. So between 35, we must be adding 1. So this value is 36. Between 36, we must be subtracting 2. And from 34, we must be subtracting 5. Okay, well, now let's look at that the other direction. Well, we know we subtract 3 every time we go over, but you now need to be careful. The reason you have to be careful is we're moving in the other direction. So what that tells me is I have something right here that when I subtract it by 3, that gives me 7. Well, that would mean that you'd have to have 10. 10 minus 3 is 7. You could do that process again to find this other value. 13 minus 3 would give you 10, and now you know the changes to find this last spot. 2 ways to look at it. 1 plus 13 is 14, or something plus 10 is 24, and again, 14 works. That is all for this lesson. Again, this is 1.3, the difference between quadratic and linear rates of change.